What algebra have we been using up to this point that's been useful? Factoring, right? You can try and factor this if you look at it as being like a difference of cubes, right? Isn't this something cubed minus something cubed? Oh man, but that just seems tedious. So maybe there's something a little easier. How about if we just expand 2 plus h cubed? Just like multiply 2 plus h times 2 plus h times 2 plus h. And maybe this is a nice spot for me to put a little scratch work in here. Scratch work. What's 2 plus h cubed? That's 2 plus h times 2 plus h times 2 plus h, right? That does not become 8 plus h cubed, right? You have to multiply this all out. And how do you multiply this? I always like to start with the second two. I FOIL those, right? FOIL those and you get 4 plus 4h plus h squared. So I actually did the FOIL in my head and combined like terms. And then how do you multiply this out? The way I always teach my students is you start with the first term, the 2, and you multiply it times everything in the other set of parentheses. And then after you do that, you'll take the second one, and you'll multiply that times everyone. So how many multiplications am I going to have total? 6. So I'll have 6 terms, and I'll have to combine like terms. So I'll get 8 plus 8h plus 2h squared plus 4h plus 4h squared plus h cubed. And if you're keeping score, these were the first 3 from the yellow multiplication. Those are from the greens. Do y'all agree with that? Collect like terms. 8. Let's put it in descending order also. H cubed. How many h squareds? 6h squared plus 12h plus 8. So that's what I can replace that one piece with, right? So I'm going to go back up to the problem and replace it. Oh, I can actually fit it on the screen. Okay. H cubed plus 6h squared plus 12h plus 8. But what was next to that? Because remember, I did the 2 plus h cubed as my scratch work. I still have minus 8 there, don't I? That's a great thing. All divided by the h, right? The 2 8s at the end cancel. And then everything you have left in the numerator has an h in it, doesn't it? So what can you do if everything has an h in it? Factor out an h. Should I still write limit? Yes. I have not let h become 0 yet. I'm still doing work here. H comes out, h squared, come on, plus 6h plus 12, all divided by h. Cancel the h's. Still write my limit. Limit h goes to 0 of h squared plus 6h plus 12. And now that's just a polynomial. Direct substitution, you get what? 12. And do I write limit? No, because I've actually let h become 0. When h is 0, h squared, 0 squared, 0, 6 times 0 is 0, you have just 12. Yes. Yeah. I'm just showing all the detail. The question was, can you skip that last step? Like if you're here at this one right here, can you go from here to the answer to this? That's fine. My whole thing with showing work is that, you know, I expect to see something, but if it's wrong and you don't have work, then it's like wrong. But if it's wrong and I see where you made the mistake, then you get partial credit. So the more you show, the better. That was number 18. So here's the graph just to show you. As we approach 0, right here, 0 on the x-axis, it looks like from the left and from the right we're headed to the same place, and it's headed towards 12. But in fact, there's a hole there, isn't there? Again, there's a hole that we can't see. I think we should do one more, and then we'll take our break. Number 20. So we have limit x approaches -1, x squared plus 2x plus 1 over x to the 4th minus 1. So I'm not going to take a whole lot of time to plug in, but you should get 0 over 0 here. And that's going to require then some algebra or some sort of trick. So factoring has been pretty good to us. And we have a trinomial on top. And what do we have on the bottom? Anyone recognize x to the 4th minus 1 as something? I mean, if I wrote this, would you recognize that? That's a difference of squares, but it's just written in it's just a 4th degree, so it's not, it's going to factor just like x squared minus 1, except that it's not going to be x plus 1x minus 1, it's going to be x squared plus 1, x squared minus 1. So I'm going to do the factoring now. The top is x plus 1 times itself, x plus 1. The bottom is x squared plus 1 times x squared minus 1. Do y'all agree with that? Does anything cancel? Not yet. What do I still need to do? I still have a difference of squares in the denominator. So I'm going to go x plus 1 times x plus 1 over x squared plus 1 can't be factored, right? But x squared minus 1 can be factored. So I took this piece here, turned it into these two. And now I get some cancellation, don't I? It doesn't matter which one I cancel. One of the x plus 1s goes away. So what we get now is limit. I'm still writing limit. Limit x approaches -1. I have an x plus 1 on top. I have an x squared plus 1 on the bottom. And then I have an x minus 1. And now let's try direct substitution. What do I get on the top? 0 over let's try this. What would happen if I square it? -1 squared is 1, isn't it? 1 plus 1 is 2, right? 2 times, and then you plug -1 into here. -1 minus 1 is -2. So I get -2. So I get 0 over -4, don't I? What's 0 divided by -4? 0. Is 0 a number? Yes. That's not division by 0, is it? No, that's okay. That's okay to have. That's a good thing. We just don't want it the other way around. So my answer is 0. Now, technically, I should come back and erase this arrow and make it an equals. But, I mean, I would accept this on a test. Well, because I did direct substitution and it worked and it gave me a number. Whereas opposed to the arrow up here, I did the arrow because I was like trying to see what happens, right? I get 0 over 0. I don't want to say that that equals 0 over 0. What I want to say is that's where it's headed. Now down here I did the arrow because I didn't know where it was going to go, and it turned out to be 0 over -4, which is good. That's a number. So if I replace the equals, it's okay. All right. We'll stop here. We'll do 10-minute break. So 2:50, we'll come back, and we'll continue. All right. So I'm curious to know before we proceed too much that, you know, obviously I put a lot of effort into everything that I can do to help you as a student, but sometimes I feel like it might be overkill, like you just prefer me to get in here, get up on the board with a marker and just do work. So I want you in the next, you know, couple of weeks, first, you know, maybe after next week we'll talk about it again. I'm always open to changing the format and just going to like a traditional course, but you know, I need you to kind of give me some feedback on that. So just keeping that in mind. You know, like this, there's a lot of things I like. You know, I'm not standing in front of my own work. You're not having to look around me. You know, it's being recorded. That's all great, but it's, I don't know, just I feel a little disconnected from y'all back here. So we'll just see. We're going to continue working examples, but I think it's probably a good point right now to talk a little bit about why we're doing this. All right, because we get into these limits and it's like, okay, what's the point, right? So all of this is leading us towards one of the fundamental questions that was asked by humans thousands of years ago, and that the two fathers of calculus, who are Isaac Newton and Leibniz, those are the two people who developed calculus on their own, independently. They didn't know each other. They're different parts of the world, but at the same point in time, they both created calculus, and they were trying to get their heads around a fundamental question. And the best analogy I could give you is something that everyone could relate to, is the idea of speed or velocity. So if you think about speed, speed is defined to be the total distance, oops, I have no idea why that little time stamp, whoa, where'd it go? Total distance divided by the total time. I know that's supposed to be an A. This marker's really causing, or this writing utensil is not working the way it's worked in the past. So when you are driving somewhere, let's say, and you have hours here and you have miles here, and let's say you start, you know, 0, 0. So you start a watch, you haven't gone anywhere, you start your clock, you start driving somewhere, right? And let's say after 2 hours, you go 80 miles, right? So at the end of 2 hours, you've gone 80 miles, that's where you are. This is where you started. Then if you connect these 2 points with some sort of curve, right? That's going to show you exactly where you were at every point in time, right? So if I go and I pick some spot here, like here, and I go up to my graph, okay, at that point in time, that's how far I had gone, right? And at every point in time, I have a certain distance. Then what is your average speed? I should have put average in front of speed here. Average speed. What's your average speed for this whole trip? 40 miles per hour, right? But it's actually, geometrically, isn't it The line connecting those 2 points, isn't it the slope of that line? Do y'all remember we use m for slope? Slope is rise over run. The rise here was the 80 miles.